All right, good morning.
Okay, let's get it started. Dzień dobry.
Dzień dobry.
Hello.
We have some very important business to take care of
Yeah, definitely.
before we get started.
Sure.
I want you to all, when we say open source, you need to all smile, pretend like you're happy, and then we're going to take a selfie. Yeah, exactly.
Sure.
Stand there. Okay. Hold on. Pretend
Wait,
like you're
because
happy.
You're so small.
Yeah. Okay. Ready? On our marks. 1, 2, 3. Open source. And then over here now. Okay, my goodness, get over here.
Come on.
You're not doing a good job, folks, on the other side. So I'm going to count on you on this other side to do a better job. Okay? 1, 2, 3. Open source. That was terrible. Just terrible. Crap. Try again. Ready? Open source. That was just
Sweet.
crap. Well, very good.
So we can go now, right?
Yeah, we can go. It's all over. That was the highlight, and I've got nothing now. Welcome, everybody. Very good. Come on in. Have a seat. Please do.
If you still can, there are some places here.
Yeah, there's
there.
2 spots right there on the stage. We've got a lot to cover today, don't we?
A lot.
Just a lot. So if you are trying to follow along, that's fine. Grab that Git repository on the slide there right now. Take a photo of that. Keep it for reference for later. We're going to go through so much, and I don't expect everybody to remember everything. That's okay. You don't have to remember every line of code that we type. And just instead remember that it's possible and that it's there.
So before we go to the main topic, a few words about us. So my name is Marcin Grzejszczak. As you can see by looking at my name, I'm Polish. So I work at Pivotal. Who knows Pivotal?
Woohoo!
Okay, quite a few people. So for those who don't know, we're doing, for example, Spring and Spring Cloud, and in Spring Boot. I'm the member of the Spring Cloud team, focusing mostly on those 3 projects, so Sleuth, Contract, and Pipelines today. We'll be working with Spring Cloud Contract. My Twitter handle is @mgrzejszczak. For those who can't pronounce it, go to my blog, toomuchcoding.com, and the Twitter handle is somewhere there.
A little bit about me. My name is Josh Long. I'm so happy to be here. I'm a Spring developer advocate on the Spring team, and I've been as part of my work on the Spring team for the last 8+ years. I have been a contributor to a lot of the open source projects. I have the distinguished record of being the number one, top-ranked, most visible, most highly acclaimed, most lauded, most prolific contributor of bugs. But still number one contributor across all the projects on which I commit. More bugs per commit. Thank you. There's that, and I'm a Java champion, and I do training videos and books and so on. So I just finished up the second edition of Building Microservices with Spring Boot live lessons with my friend, the one, the only, the amazing Spring Boot co-founder Phil Webb. And I just finished my 5th book with my friend Kenny Bastani, who, by the by, is here at DevX Poland, and I encourage you to go find his talk when it's on. And we just finished our book. It's called Cloud Native Java. And among many other things, of course, it talks about how to build applications that survive and thrive in the cloud with Spring Boot and Spring Cloud and Cloud Foundry. And of course, we talked about Spring Cloud Contract in that book as well. And for those of you who are wondering, and I can see it in your eyes, I can see the curiosity welling up in your eyes. For those of you who are wondering, that bird on the cover is a blue-eared kingfisher. Anybody who knows anything knows that nobody cares what's in the book at an O'Reilly book. It's the cover that makes the book. People buy the book or don't buy the book based on the animal. So we did a lot of work. That bird is a blue-eared kingfisher. It's a bird that is indigenous, or in English we would say native, to the Indonesian Java Islands. It's a bird that is native to Java. And birds fly, often through the clouds. So it's a bird that flies through the clouds and that is native to Java. It's a cloud-native Java bird. It's a bird that, never mind, it's fine. Give it time. And so there's that, and we both have the distinction, the privilege of working at Pivotal, and we have a lot of good open source software at Pivotal, and we care very much about the open source software. You may recognize some of the icons from the slide, whose art, by the way, was contributed by my teammate, Ashley McNamara. Some of the icons are here, but there's other projects like Apache Tomcat, right, RabbitMQ, etc., right? Lots of different technologies at Pivotal, and we care about that, but let's be very clear. It's not the thing that drives us. It's not what motivates us. It's not the reason we spring out of bed. What we care about more than anything else is helping customers and community members and organizations and so on deliver value faster and safer to production. And we see that a lot of organizations struggle with this. We try and help them as best as we can. And part of that move seems to be this sort of exodus to this microservices architecture, because it allows organizations to decompose larger batches of work into smaller batches, microservices, and that in turn makes it easier for teams to sort of stay small and lean and reduce the cost of synchronization, right? Instead of having a large group of people with whom you need to communicate, you have a small team, and the cost of preparing and deciding about change is very, very small as compared to a large team, right? Microservices enable organizations to go faster. And this is not a new or a controversial idea, right? This is sort of the natural evolution of Conway's law, right? And Conway's law says that organizations are a mirror image of the communication structures that build them, right? Of the teams of the communication structures of the teams that build it. So if you have an organization that doesn't do a great job of communicating, then you are necessarily going to do a poor job of building software that talks to each other. And this has been borne out in lots of different studies over the intervening decades, in the last 30 or so years since Mel Conway had this insight. The one example was a study that looked at open source software and compared it to proprietary software. Something of analogous form and function. Imagine you had the opportunity to look at the source code, to stare into the abyss, into the oblivion. Imagine you had the opportunity to look at the source code for Microsoft Office. What would you see stare back at you? After stifling the considerable, endless amount of vomit, imagine what that code would reveal to you if you compared it to something of analogous form and function like OpenOffice. What they realized in this study is that open source software, as developed by open source teams working in different time zones and different languages and different hours at different capacities, tends to be much more modular than equivalent software developed by the same team in the same office, in the same time zone, in the same hours, working in the same capacity. And the reason is obvious, right? The cost of communication is cheaper, so there's far less need to have modularity. If I want to make a change and Marcin and I are in the same room, I can just say, hey, buddy, what do you think of this? And we can have a discussion about it, we can refactor. But if you're in different time zones, it's very hard for everybody to get on the same phone call, let alone the same room, right? The cost of communication is much harder. So they optimize their ability to go faster by stabilizing their API boundaries, and that becomes the communication channel. The teams speak to each other through APIs. That's how they get past the need to have lots of discussions. As long as they stay within their API boundary and they keep that stable, everything's fine. The problem comes, of course, when they don't keep that API boundary stable. Then you need to do that very costly communication, and it's much more difficult, right? Because now you've got different pieces of code. So today we're going to talk about a way to get around that problem, right? We've talked about Spring. He and I have both done countless talks on Spring Cloud, which helps you build robust services that do the right thing at runtime. But now let's talk about building robust communications, right?
Let's try at least.
Let's try. We'll give it a go, right?
Hopefully the demo gods will help us.
Oh, yes. So we're going to build a sample application as we do. We're going to build a hypothetical sort of car rental service that talks to another service, a consumer that consumes an API from a producer, right? And that's really what we care about. We don't care all that much about the domain of building a car rental service, and we don't care about the domain of building a fraud detection service, right? These are the examples, but let's not pay too much attention to that. What we care about is a consumer consuming an API from a producer. So I'll go ahead and start us off.
Yeah, so whenever Josh is writing some code, he's going to either send a request or receive a message from me. So whenever I'm coding, it's going to be the second app, the producer app.
So we're going to build a car rental service. We're going to build a new application.
What is this page?
This is my second favorite place on the internet. Anybody who knows me knows that this is my second favorite place on the internet. Can anybody tell me what the first favorite place is? Production. I love production. You should love production. You should bring your friends, bring your family. Go as early and often as possible. Production is the happiest place on earth. It's better than Disneyland. I love production, and so should you. You should go as early and often as possible. But if you're not already there, then you begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and can't sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a new application here that takes advantage of Spring's web support. We're going to use the actuator for observability, and we're going to use the stub runner and the WireMock dependency, yeah? Anything
Lombok.
else?
I mean, they
Lombok,
give the
yeah.
dependencies for free, so let's take them.
Yeah, absolutely. Lombok is a
Stream Rabbit maybe as well.
RabbitMQ, stream processing, good points, so Rabbit Stream, very good. So we're going to hit generate, and that'll give us a new project that we can open up in our IDE, and it doesn't really matter which IDE, right? We talk about this all the time. It doesn't matter. We're going to use IntelliJ here, but you can use whatever you want. Quick show of hands. How many of you are using IntelliJ? Just curious. Very cool. How many of you are using Clips? Right on. Very good stuff as well. What about NetBeans? NetBeans? Right
Yeah,
on.
two
Awesome.
people.
No, that's cool. What about Emacs? Are you here, sir? Emacs guy?
Over here, there he is.
Oh, there he is. See, every talk I do, every city, country, and continent I go to, I ask who uses Emacs, and he raises his hand. It's the same human being, the same object identity. Who uses Emacs? I do, and then he leaves, presumably to go to the next conference. No. Okay. So we're going to write a test, right, in the test-driven style. Maybe I should change the font. Can you all see that in the background? Control-Alt-S. Font. Go, computer, go. Bigger, okay? Very good. So there we go. We're going to write a test, and we're going to write a test that talks to our fraud detection service. So we're going to say public, come on, public void test should return all frauds, right? And our test is going to just call the REST API using the REST template, which is the Spring Framework HTTP client. It's a workhorse that makes it easy for us to talk to other HTTP-based services. And so let's assume that we've got the service running on port 8081, and we're going to call the fraud endpoint, and we'll say string.class, and we're going to assign the intervening value to a variable here, a response entity, and then we're going to use that. We're going to use the BDD assertions from assert_j to assert that get status code value is equal to 201, and then we're going to do the same thing for the body. We're going to assert something about the body that gets returned as well, and so we're going to say that the body is equal to this JSON string here. So JSON, and we'll create some JSON strings.
Java's perfect language to write JSON there, right?
This is perfect. It's the best language for this.
I mean, JavaScript contains Java, so
It's the
it
same,
has to be like
basically the
related.
same. So we'll use that, and there we go. So there's my test. Now, of course, this isn't going to work, is it? I don't have that service running. So a natural thing to do here would be to use wiremock, and I can just say @autoconfigure.
Who knows wiremock?
Wiremock.
Who knows
right?
wiremock? Raise your hand. So for those who don't know it, wiremock is a stub of an HTTP server. So as you do it with Mockito, like given you execute some method on a class, please return this, you can do exactly the same thing with the API, with HTTP. So what Josh is doing is that if a request with the method get is sent to URL frauds, please return the status, please return a response with status or body with the JSON and status to 101.
Right, and we'll use this body here, the JSON. There we go. So there's my wiremock endpoint, and we've got our test. We're basically mocking out the API to which we want to communicate, and we're going to hit run, okay? So I'll run this, and let's see. I guess you need to be able to write code for this to work. Okay, here we go. Take 2. All right.
You have to set the port still.
Oh, yeah.
My
What
friend.
about the port? Port equals 8081.
These are, I mean, this is why we write tests, because something doesn't work, it should break, right?
Today we're going to do the only talk. I think we have the privilege of giving the only talk where every single bug we run into is a feature. So there we go. There's our good code. Seems to be okay. It seems to be fine. What do you think of that?
I mean, okay, it seems to be working. I mean, I wasn't listening to what you're saying.
Yeah.
Because that's boring.
That's fine.
So, I mean, I heard something. I'm going to take this knowledge and try to write the other app.
You're going to build the implementation,
Yeah,
right?
yeah,
we're doing red green
like
refactoring.
move
basically.
aside and give space to professionals.
Right, of course.
Okay, so I'm going to write the fraud service app. I don't need the stub runner. I need a verifier, and I need res docs. Res docs. Okay, let me generate that fraud service. Now I'm going to open a new screen here. Unzip fraud service. Let's open it. Hope it's going to work. Yep. So because actually I don't trust this guy too much. He's known for making bugs. So I'm going to formalize our agreement, right? Because he said that if I send this request, then you will reply in this way. So I don't trust him. Let's formalize that. So under source test, I'm going to create a directory, resources, contracts. So a contract, assuming that this will work, okay. So a contract is an agreement between the consumer and the producer on how the API should look like. So let us define this. Should return a list of frauds. I'm using Groovy. Who loves Groovy? Okay, not many people. Who hates Groovy? Okay, stop it. We're going to use Groovy, but the good Groovy, because it's statically typed. So the IntelliJ, the IDE, will help me all the time in writing the code. So you need a description. It's like should return a list of frauds. Oops. And then we have a request and a response. In HTTP, you send a message, you block until you get the response, right? So he mentioned something like URL should be fraud, right?
Yeah,
fraud.
Sure.
Fraud. The method get, right?
Yeah.
Something like this.
Sounds right.
Status 201. And the body was like an array, Marcin and Josh, I guess. Okay, fair enough.
So what did you just do? You created a contract. What did you just describe?
So I described the communication between us, but it's not a schema, because we don't care about all the possible request fields and all the possible response fields. We care about a certain scenario, that for given this particular request, please respond like this.
So it's not meant to actually implement the service, it's just meant to provide the minimum sort of possible response.
Precisely.
Okay.
So now I'm going to add a plugin, because the fact that I only wrote the contract doesn't mean a thing. The contract needs to always speak the truth. So how can you verify the truth? By running a test. So we're going to add the Spring Cloud contract Maven plugin, artifact ID, Maven plugin. Version is 1.1.1 release. Extensions is true. And configuration. I'm going to add something called a base class for tests.
And what does that do?
So let me just first add it, because I can't speak and write at the same time. So what will happen is that tests will get generated. So we need those generated tests to extend from a base class if we wanted to set up some configuration for the generated tests. So I'm going to add the base class over here.
In our test directory?
Yep, base class. Okay, and now I'm removing the test that was by default created here. Oh, sorry, there's a typo, so it wouldn't work. Base class. Okay. And now, let me run, for service, let me run Maven clean install. I had no tests, right? I removed the test. So we're running the stuff, and suddenly I have a breaking test. I mean, what happened? So if I go to target, we have generated test sources, contracts, verifier. And when I said that if you have a contract in which you say that if you shoot a GET request at fraud endpoint, return to 101 and certain body, I'm actually checking that. So I'm creating a GET request, I'm sending that to your endpoint, and I'm expecting certain response, but you don't have it, so it's failing. So what I need to do, I need to do two things. First is to add the missing controller. So where's controller, class fraud controller, and we have the, it was fraud, right?
Yeah,
Fraud, something like
sounds about right.
Response entity of list of string.
So this is just a basic Spring MVC controller?
Fraud, yep. Let us add the missing dependencies. Response entity status will be 200, that's what you said?
About right, yeah.
And arrays as list is Marcin and Josh, right?
Sounds good.
Okay. And now I also need, since we're in the generated test, we're using rest assured, we need to set it up. So we do Spring Runner, Spring Boot test.
So he's using the Spring MVC test framework and the Spring Boot testing framework, which makes it easy to stand up a context and then talk to objects. But you can mock out the things that are expensive, and you can isolate the objects on which you want to act as well by using mock beans. This is very convenient because now we can just focus on the thing that we care about.
Yep. So we have rest assured mock MVC, and I say, please set it up for the fraud controller. That's
Right.
it. So of course, the very essence of this talk is that, I mean, we never make mistakes.
Never. It's not happened yet.
So these tests will pass.
I'm sure of it.
Of course. No. Okay. Okay. Oh, yeah. Because it was supposed to be. It lied to me. It was supposed to be 201, the status. So I didn't pass the contract I stated, right? So already some bugs, minor things are caught here. So if like in the implementation, I was supposed to do 201. Yeah, my bad. Sorry. So if we rerun it, hopefully it's going to be built. So the first thing that the plugin does, it converts the Groovy-based DSL into a test. And the second thing it does is that apart from the fat jar of the app, we're creating also a stub jar. So you see, with a classifier stubs. What is that? If you're using WireMock, you can use it like Josh did, so with code. But also, you can use the JSON notation. So if you go here, you will see that from the DSL, we've created also a JSON WireMock definition, so definition of a stub. This is the perfect bit. I mean, everybody loves embedding a JSON in a JSON. So we're doing that for you. You don't have to do it. And we're installing it in a jar locally in our M2. So the last thing I'm going to do, because everything seems to be working, I'm going to start this at port 8082, maybe.
Sure.
And off we go. There you go.
Okay, so what did we do? We wrote a contract, and the contract describes the interactions with our downstream service, the fraud service. And now that you've got that service up and running, you've made the test work on your local instance, on your fraud service implementation. Your contract is actually talking to your fraud service.
Yep.
So within that module, everything's green.
Yeah, and
I mean,
it's also green on your side, so
Right.
I mean, it's going to work, right?
It's going to be work. We can just start them up, and they should be able to talk to each other now, right? So let's go back to the car rental service.
So actually, we don't really need to even test it because the tests have passed, right?
Right.
But let's do it. I
It's
mean,
formality, really. But let's go ahead and create an integration test, yeah?
Yeah.
Okay, so I'll say integration. I'm just going to I'm going to copy that old test that I had before, and this will be an integration test that doesn't have WireMock in place, right? We're just going to talk to the actual service that's running on that other port, and that's on 8082, I think
82.
he said. So that should be all I need to do, right? I don't actually need this either. So let's just go ahead and.
no, I mean, you need it for a session.
That, right.
Who thinks it's going to pass?
Should pass.
Who thinks it's not going to pass? Who doesn't care? Okay, there is. Who didn't raise their hand? Okay, a lot of people.
So there we go. Let's run both of them. We should see green all the way. Oh. What
I mean,
is that?
it's impossible. We had tests on
The tests
both sides.
were green.
So what happened?
We got a 404. That tells me something obvious. Is the right port, 8082?
I mean, didn't you say like fraud?
I said
So there's a
fraud.
typo. It should be
Okay.
fraud, not frauds.
Let's fix that.
But we had tests, right?
They were great tests. The best. Okay, there we are. That's green. Seems consistent. Well,
Yeah,
we should.
That's embarrassing.
That is a little embarrassing. That must be very awkward for you.
Yeah.
We
feels
need to
bad.
find some way to fix that. I don't want that to happen again. Maybe we can use that contract you just built to sort of safely talk to that service and get an idea of what that service looks like. Is that
Yeah,
an
because I
idea?
mentioned that we are installing stubs from the producer,
Right.
and the stubs were tested, like so to speak, against that producer.
Right.
So they're actually telling the truth.
They reflect the truth as far as that producer knows it.
Okay.
Right. So let's take advantage of that instead. Let's go ahead and build an application that stands up stubs. It runs the stubs for us, right? And we're going to do that using a rule here, a JUnit rule, rule instance, and it's going to be stub runner rule. And the stub runner rule is going to download the stub, which we've installed under the following Maven coordinates, right? Is it fraud service? Yeah.
I guess so.
Okay. And we're going to work offline. That means we're not going to try and resolve them against Maven public repository. And then we're going to use the following port, which
8083 maybe.
8083. I'll take it. 8083. Okay. There's our stub runner rule. So when JUnit runs, it's going to start that application up, and we can now change this and run it again. Okay. Now remember, the other one, the real one, is running on port 8082. So if all these tests pass, and they did, it's talking to the mock, not to the real thing.
Yeah, so if we change this to frauds and run it again, what will happen?
I'm hoping that it'll catch our mistake, so we don't run into this again. Oh, look at that. So our stubs gave us an API against which we could talk, but it's a cheap API. We didn't have to deploy the whole service. We didn't have to do an integration test, basically. We don't have to deploy virtual machines or containers or anything like that, right? We've got the ability to stand up a very, very lightweight HTTP service that responds as we expect it to, and that reflects the reality of the service to which we're connecting. But this still, I'm just going to go ahead and say it. This is nice and all, but we don't need this if we were using something truly decoupled and robust.
I mean, obviously,
this is the protocol.
It wasn't our fault. It was the fault of the protocol.
Right, absolutely. HTTP is
actually,
coupled.
nobody uses HTTP anymore. It's
right.
not.
No.
It's not. Fun to do it. We need something
decoupled.
Decoupled and asynchronous.
Asynchronously decoupled.
Yes.
I want it to be decoupled later, right?
I mean, obviously, this was the reason for the whole problem.
Right. The protocol's the
Yep.
problem. Let's try something else.
Okay.
Let's do something more robust, more decoupled, more asynchronous.
So let's do it like this. I'm going to send you a message.
Okay. Send me a message. So I'll write a code. I'll write some tests here to sort of work through how I want that message to be processed, right? Okay, so we'll try that again. This time we're going to do messaging. And we can use Spring Cloud Stream. Spring Cloud Stream is an abstraction that lets us talk to other services in terms of message queues. Spring Cloud Stream builds upon Spring integration, and it supports communication thanks to something called a binder. And there's lots of different binders out there. There's a binder for RabbitMQ, for Apache Kafka, for JMS coming up. There's one for all sorts of different technologies. And these binders, they let us write code in terms of channels. And a channel is just basically a pipe through which data flows in and out, right? It's a Java util queue, basically, in memory. But those queues are connected to actual brokers, like RabbitMQ. So you put something in the queue, and it gets sent out to the broker. You expect a message to pop out of the queue, and you can process it in your code. We don't worry about connecting those queues, those channels, rather, to the broker. That's what Spring Cloud Stream will do for us. It becomes just a matter of convention and configuration. So let's go to our code here. And let's update the code to accept a message that comes in off the wire. We'll create a POJO here called a fraud entity, and we'll use Lombok here to say that this is going to have all arguments and no argument constructor, and it's going to have getters and setters. And the fraud is going to have a field here called name. Okay, so there's our field. And what I want to do is I want to write some code that listens for messages coming in on a channel. And now I have to tell Spring Cloud Stream about that channel. I have to tell it the definition of that channel, and we do this using an interface. Now that interface, you can provide your own, but for the common case of taking data in from a channel and for sending data out from a channel, there are some predefined definitions. Here's one for the input channel, right? Data coming in on an inbound sort of request. This interface has a channel definition. All of this other stuff is extra. You don't really need it, but in our case, it makes it easier to say and to distinguish that we want this particular channel in our code. So we're going to say to Spring Cloud Stream, create a reference, create a hydrated object that looks like this, and then connect it to our broker. And we'll look at the configuration for that here, right? So we'll say Spring Cloud Stream bindings.input, which is input is the name of the channel, .destination equals fraud. Okay?
So this is the queue, or like
this
the topic somewhere in the broker, right?
Yeah, this is the broker. This is RabbitMQ or Apache Kafka or whatever. This is the agreed upon rendezvous point in the broker against which both producer and consumer must agree. And then the thing over here is a channel definition in the interface, right? So that's going to change from one code base to another. So with that in place, we can now write a component that listens for messages. Now, right now, I don't want to talk to the actual broker. I want to do testing, right? So we're going to test using the messaging support in Spring Cloud Stream. So stream test, okay? Whoop, and we'll say scope is equal to test. Okay. Now I want to write some code. I'm going to say public void on fraud message fraud. Okay. And what we need to do is to tell Spring Cloud Stream to listen for messages coming in from the input channel. And I could have just said input, since that's the name it has, right? But I'm using that convenient variable in the interface itself. And what I want to do, just for our purposes, just to get something working and to prove it's working, is we're going to observe the incoming message and then note the name that's observed. So this dot name equals f.getName, right? And just for convenience and just for ease of understanding, we'll also log the incoming message. So we'll say this.log or just log.info. This name is that, this.name, okay? So there we go. That looks okay. We should write a test,
kind of,
right? So let's write a test. We'll say Control-Shift-T, create a new test. And what we're going to do here is we're going to talk to test infrastructure using Spring Boot. So we'll say run with Spring Runner.class, and we're going to create a test that sends a message into the channel and then asserts that it behaves as we expect it to on arrival. So test should consume fraud message. Okay? Throwable. And to confirm this, we need to inspect the state of the fraud listener, right? The resulting state, and we need to have a reference to that sync, right? So we can send a message into the sync definition. So we're going to say message builder with payload, and we're going to create a new object, a new message that we can send into the channel, right? We're going to send a message of type fraud into the channel. So I'll say message equals message builder and build, and then of course we need to provide a payload. So we're going to create an instance of this fraud, and we need a name. Can you think of a good name we can use for this? Something easy, concise, and easy to remember and type on the stage here.
So you can pick one of the two. The first one is Grzejszczak, and the other is Brzęczyszczykiewicz. So which one? I mean, you can also type in Chrzęszczyżewoszyce if you want to.
The first one. Okay. Let's do the first one.
Grzejszczak.
Just spell it. So
Grzejszczak. Grzejszczak. Yep, that's it. Yeah.
Okay.
Good.
Okay.
I didn't like this part.
That's about right? Is that right?
Yeah, something like this.
Okay, there's the name. So we're gonna have a message that comes that we're gonna send into the channel. So we'll say sync.input, and we're gonna create a definition. We're gonna dereference that channel and send it into that. So we'll say input.send message. Okay.
Yep.
There we are. There's our code.
We need to assert the.
Oh, we need
state,
to confirm the results, right? So we say bd assertions dot then this dot listener dot name is equal to
Grzejszczak, type it in.
Yeah, I'll just use the variable if you don't mind. Thank you. Okay, so there we go. That should be okay, right? Looks okay to you? Do we need anything here?
No, that's okay.
No, that's fine for now. Let's go ahead and run it. Here we go.
So you built a message using the Podio you have there.
Right.
You send it in memory to yourself. You check the listener got it, and you asserted that the name is okay.
Right, and we can even see that reflected here on the console as well. Everything seems fine.
Yep. Wink. Yeah. So, so the build is green. So
green.
Yeah. So let me write my part. I'm going to send you that message.
Let's just wrap this up.
Okay.
We're winning.
So again, I don't trust him. So
hey.
let me formalize this. Should send a fraud message. Groovy. So we define a contract. Make. You have a description. Should send a fraud message. And now we need something called a label. So something that can, let's say, we can reference this particular message via this label. So let's say trigger fraud. Is it okay? Make sense?
Yeah.
And now with HTTP, you have a blocking call. You send a request and you wait for the response. With messaging, it's not the case. Suddenly something happened that triggered a message. A message is there on the topic or in a queue. So there's going to be an input, something that triggers a message. In our case, it's going to be a method. Trigger message.
And that's going to be in the base class itself, right?
Exactly. So in the generated test class, you will see in a second that we call a method called trigger message. So the code won't compile because we didn't define this method. We have to define it in the base class. Now we will send it to, was it frauds?
Yeah, that sounds about right.
Okay. And the body, there was my surname there. Okay. Can you type it in?
Oh, please, after you. I just want to test you.
Fair enough. Okay, so if I run this again, it will, like the plugin will see that there's a new contract. It will regenerate the test and say that there's no method called trigger message. So if we go to the to here and check out the class, we'll see that there's a new test that triggers the message and expects the message to be there on destination frauds, and the surname should be my name, right? Okay, so how can we fix that? We need to add the missing method to the base class, public void trigger message. Now, actually, we need to trigger that message. First, what we need to do is add a magical auto-configure message verifier annotation to tell Spring Cloud to set up all the messaging machinery for the test. The second thing that we need to do is to add the test dependency, as Josh did on his side, stream test support, and with scope scope test. Fair enough. And now we need to somehow trigger that message. So let's say that we're going to have a post mapping to the message URL, void message, and we need to send it somehow. So you're using sync for the input. I'm going to use something called a source for the output.
You're going to be the producer of a message. You're the source. I, as the consumer, I expected messages to come in. So that's the sink, like a faucet. The water goes into the sink, right?
Exactly. So I have enabled the binding. Now we need to do the same thing with the binding as you have. So for the output channel, because you are the input, I'm the output.
Right.
The destination is frauds.
Right.
And the content type is application JSON. So we do some sort of like technical configuration.
Content negotiation.
Yeah. Okay, so now in the fraud controller, we need to send the message. So we do source output send message builder with payload build. So we need the payload. So let me do similar stuff to what she did. No args constructor, class fraud, and there was the surname there, right?
Right.
Okay, now let me do new fraud. Grzejszczak. Okay, so if
rolls right off the tongue.
So if we run this, hopefully I didn't make any mistakes. So that should.
I've not known you to be a person who makes mistakes.
Of course. Something is not great, but that's good. Tests are like to check it out. So what do we have here? In the base class, in the contract, we said that we're sending frauds. Oh, I know what's wrong. I have to refresh this project. Okay. So we said, let's check it out. So we said that we're going to send the message to frauds. In the application.properties, we're listening to frauds. So that should be okay. Let us run it again. Hopefully. Demo gods, please. Okay, it worked on my machine.
There you go. There's a fail.
Okay, let's check it out again.
The app's still running.
Let's close the app. The stream test support is here. Let me refresh it. Again. You can tell a joke in the meantime, maybe.
That one joke I know?
Yes. Listen to frauds. Let's check the exception.
What's the error? Yeah, no pointer.
No point. I like no pointers.
The most useful kind of pointers.
Surname. This is interesting.
Trigger message label.
Okay, surname.
Source.send
looks good. Let's run it again. For sure, you have to run it a couple of times.
Give it a lot of chance to really shake out the bugs.
Okay, so in the meantime, I know what we can do because, we have a special folder on the desktop which is called.
Well, let's see. Do you want to try and fix it?
Back,
we can
which
try
is
and fix
for
it.
backup.
It doesn't actually have the backup.
Oh yeah, that's true. Okay, does anybody see a mistake here? Come again? It's missing where? No, it's not here. It's in the message endpoint, source output, send message with payload. Oh yes,
You forgot to call.
Of course, thank you.
Good call.
So that's a perfect call. So what happened is we did nothing. That's why we got no message.
Right.
Thank you. If I had a prize for you, I would give you one, but I don't.
We have a copy of the Spring framework you can have, open source.
So we need to call the message. Yay! Thank you so much. Demo gods are evil. But that's actually something that already catches all sort of mistakes, like stupid ones that I make. Or, for example, the content type is wrong, or there are typos and stuff. Okay.
It's beautiful.
Finally, it's beautiful. So what I'm going to do, I'm going to run both apps.
Yeah.
And just check if things are working. So
sounds good.
We have 8082 over here. Now let's run this thing.
The app itself, not the test.
Yeah. And by the way, you had a running RabbitMQ instance.
Right, on my local machine.
Yeah, so both apps have, let's say, bound to the same broker. So now if I curl a request over here to this local host 8082 to the message endpoint.
Should work.
I need a pause here. That should work, right?
I believe.
So right now.
It's fine. Why do you even check? We know it's going to work.
Okay, it's not working.
What'd you do?
No, what did you do?
What did you do?
It worked on my machine.
Worked on my
I mean,
machine.
it didn't, but then the guy helped me, and now it's working.
Yeah, exactly. Wait,
Okay,
no.
so,
I mean, mine was first.
Did you say fraud or frauds? Because I don't remember, actually.
It's in the code. That's the
Okay,
documentation.
let's check it out. Oh, you said fraud.
Fraud, yeah.
Oh, and I typed
obviously.
in frauds. Okay.
It must be the microphone.
Okay,
We can't hear
my
each
bad.
other.
Sorry. So let us restart it. And by the way, his tests passed, right?
Yeah, they were fine.
On his side.
We
Okay.
wear microphones when we work together, even if it's just the two of us in the office.
Okay, so let's curl again, and let's check it out. Oh, we got it, but the name is nil. Why is the name nil?
It gave up on your name.
What did you do, man? So let's check it out. Oh, you put name or surname?
Name. Man.
Name. Ah, come on. So I put surname.
Oh.
Never mind. But I mean, your
such
test.
formal English.
Yeah, your English is bad, so I didn't get it.
Yeah.
So let's run it yet again.
This time.
Okay.
It's gotta work. It's gotta work. I know that.
I mean, yeah. And by the way, I don't have to remind you that your tests have passed.
Yeah.
Okay, fair enough. Okay, let me run this curl again. Yay.
Hey.
Okay, the name is good. The name is good. Okay, so we made a lot of mistakes, and the tests have passed. So
But by
something is
running the
wrong.
integrations between both of them, we're able to see the mistakes. But that took a lot of time. We had to rerun everything each time.
So what I'm doing right now, I'm reverting the change with the name.
Right.
And Josh, how can we make things happen in such a way that we fail fast?
Well, just as we did before, let's take advantage of the stubs. And instead of standing up a fake or a mock sort of HTTP API, what we're going to do is we're going to send up a mock messaging API. And we're going to use the stubs again. We're going to use the stub runner that we used before. But this time we'll use the annotation. So last time I used a rule in my test to stand up the stub runner. But this time I'll say auto configure stub runner. And hello. Whoa. Easy. And we'll say that we want it to work offline, that's true, and that the ID of the stub is com.example:fraud-service. And that's going to bring in the stub that I need. And then what I can do now is instead of me sending all of this stuff manually and exercising the interactions manually, my stub, the stub that he created for me, already knows the kind of message I want to send and how to send it. So I'm going to just rely upon the stub trigger, okay? Private stub trigger. That's a bit of machinery from Spring Cloud Contract, and it's connected to the trigger, to the stub definition, to the contract itself. So I can say stub trigger.trigger, and the thing it's expecting here is the contract label, right? So I'm going to grab that, invoke that, and then that should send a message.
And the name should be Grzejszczak. Here, fix it.
Right. Isn't that what I?
No, not really.
Not, okay, fine. Is that all right?
Yeah, that's the one.
Wish you had written that before. Okay, so there we are. So there's the name, and let's see what that gives us. I'm expecting it to fail. That would be a success in this case. It is the bug.
Because we reverted that instead of a surname, we have a name, right? So it's better to actually run the test instead of running the app. But
quiet you.
That's
I've
good,
got
that's
this.
Good. That's good.
Got this. Okay. Okay, here we go. Good. So it failed, and the error is indicative. Yeah, it says null. The actual was null. The expected was Grzejszczak, right? So
perfect.
Very good. So what I need to do now is to go back to the Pojo here, my fraud Pojo. Where did I put that here? Carbon application, fraud, and I need to change that to what? What did you have before?
Surname.
Surname. I knew that. Just testing you. So here we go. Surname. Good. So there we go. There's the updated code. If we run the test again, things should work, right? We caught the error. We didn't have to run the actual downstream service. And we got feedback.
So you're saying that we can, let's say, break the build locally on our laptops without even starting any other applications?
Right. Unless you're Chuck Norris, it's better to break it in your test
true.
than in production. And
True.
and it's better to test in local machines than to test in production. All right, so that's awesome. But I noticed that in trying to fix that, we had to introduce that new REST endpoint, that message endpoint.
Oh, yeah.
I'll go ahead and write a contract for that.
No. Leave it to professionals.
Okay.
I mean, apart from not writing implementations in the test, I'm doing stuff properly, I guess.
Okay, fine.
So
you write the contract for the message endpoint.
Let's not write the contract.
No contract?
No. Who's using mock MVC here? Who knows mock MVC?
Okay, Spring MVC test framework?
Yeah, quite a few people. So there's a framework called mock MVC that you can use to test your API. So let's use it. So the endpoint we have here is post mapping for message. So let's write a test for that. Okay. So we're going to start with Spring Runner, obviously. Oh, thank you for killing me. fraud service application class. And also, we're going to use something called a test slice. So instead of starting up the whole machinery, we can pick only parts that we're interested in terms of writing our tests. So we're going to use a mock MVC.
That's the mock HTTP client that we can use to exercise interactions with our Spring MVC-based web service.
And the test should have a post message, whatever, endpoint. Mock MVC perform. Mock MVC request builders. So we send the post to message. We throw exceptions. And we expect mock MVC result matches status is equal to, status is 200, right? So that's our case.
Right.
Let's run this. So if we have such an endpoint, the test should pass.
Right.
Cool. So now we're going to add auto-configure resdocs. Resdocs is a library that allows you to automatically, from your test, generate documentation, which means that instead of putting all the annotations to define how your interactions look like, you can take it out from the test.
So the interactions with the API themselves generate the documentation, not annotations on the API.
Precisely.
Right. So the semantics are clear. It's what we expect them to do that generates the documentation.
So we
Spring
have manual REST mock MVC REST docs, REST documentation. No, mock MVC REST documentation. Mock MVC, yes, REST documentation. Document. Message.
So that's the name of this is the thing under test that we want to document, right?
So if we run this, what's going to happen is if we check out the target, we'll see snippets, message. So this is the name of this identifier that I wrote here. And you can see the, let's say, definition of the request and the response in HTTP that we got from the test, or the curl message, the curl command you would have to execute to replicate this particular request. So it was post factum. And for all of you who are already using mock MVC and, for example, resdocs, it's enough for you to add the Spring Cloud contract wire mock dependency, and out of the box you get the JSON stub.
So I can use that now, if I wanted to, in my client to now talk to that. The contract ultimately generates that stub anyway. So now I've got the stub. I can use that for my client to test that endpoint as well.
Precisely.
Now I've got a question. This is just hear me out. This is just a crazy thing. It's Wednesday and I'm feeling squirrely, so I'm curious. And again, this is just a hypothetical. I don't want you to get freaked out, okay? But I've heard on the internet.
And they don't lie there.
They can't. It's impossible. I've heard that there are other technologies, and again, don't get weird.
Okay.
Don't freak
And they're
out.
friends here.
We're friends. So I've heard that there are other technologies besides Spring and Java. Now again.
No.
Again,
impossible. That's not true.
Again, as a hypothetical.
Okay, hypothetically, let's say that there is something like, I'm going to just, let's say a couple of arbitrary words, like letters, Node.js, for example.
Right.
Let's say that there's a Node.js app, and the Node.js app would like to profit from the stubs. Sure, it's possible. So I will go to the special folder on the desktop, which is called Beautiful Contracts. And there is an app there called StubRunner Boot. So what I can do is execute that and say, StubRunner, work offline, walk offline as well, true. And StubRunner IDs, example, fraud service, right? So if I run, what now? Jar makes no sense. It's better to run Java jar. So we execute that. The jar starts, and the stubs are downloaded and started in a separate app. So if I go to localhost 8083 stubs, I get no stubs because I made a typo. Of course.
Go back.
Fraud.
Example, fraud-service.
Wasn't it? Oh, okay.
It didn't know what to talk to.
Demo gods, why? Okay, now it looks better. So now it's better. So I have a running stub on certain port. If I go to localhost 8083 triggers, I will see all the messaging triggers. And if I go to localhost /frauds, I get 404, but because there's no such endpoint, but fraud there is. So this is the stub that was created from the producer's tests, and it got started aside, and now in my Node.js app, I can call it without even knowing that it's a stub.
Right, that's awesome. So now, if I have a lot of different collaborating services, whether they're messaging-based or HTTP-based, I can just run these stubs, and that works for other languages and protocols.
Yep.
We've just made it, this makes it much simpler to integrate with other microservices. I don't have to run everything on my local machine. You've just solved a big problem that Apple could not solve. I don't know if you all saw the puny release of the Apple MacBook Pro that they released last year, but there's not enough RAM in that thing for any kind of sufficient distributed systems programming.
I mean,
support,
16
right?
gigs of RAM.
16
My
gigs?
Slack takes 16 gigs.
That's a joke. So this solves that. Now you can run 1,000 of these things, and they're super small on your local machine. You can get the fast feedback, and you get production-like semantics, right?
If you want to learn more about this, you can go to my talk on Friday about Spring Cloud pipelines, where we leverage that in a deployment pipeline to do continuous delivery and deployment.
Right, and this sets the foundation for consumer-driven contract testing, which is what I hope you got out of this. Thanks, buddy. This was fun.
It was awesome.
Did you like some of this stuff? Did you see the potential here?
Who doesn't care?
Thank you so much.
Thank you.